Okay, good morning. Am I audible to you? Good morning, good morning. Sambit, am I audible? Okay, very good. So, Sambit, is there any problem in the last lecture? Santan, have you any problem? Rukshar, have you any problem till last lecture? So, please do revision. Revision is very important. Now, on Tuesday uh, evening, I will discuss how should start your, what should be preparation strategies, and how should tackle the subjects. Huh? But till now, you should only follow the class notes and revision properly. Okay. So as I told you in the last lecture, what will be the differential equation for one dimensional when the area is a function of x or k is a function of temperature. Okay. Once again, I'm just going to revise the all things in 5 minutes. So as I told you, suppose if we have one dimensional, so if a one dimensional heat conduction I'm talking about, so what I told you, let's say this is what differential element, this is the differential element you have considered. Of the large element, we have considered small differential element of length dx. Clear? And then you should write here q dot at x and q dot at x plus dx. And then you can apply the energy balance. E dot in means within the control volume, minus E dot out plus E generation is equal to E accumulation. And since most of the cases we are talking about is steady state, there is 0 here. E in is simply qx, E out would qx plus dx. E generation may be there, but if I am talking about here E generation, na? Let's say we are going to consider generation also, then it's qg into volume. Volume is area into dx. Clear? That's equal to 0. And the difference of this is equal to minus of del q x upon del x into dx is equal to minus qg into a into dx. This dx cancel out, and from the Fourier's minus cancel out, del upon del x become d upon dx because it's only function of x here. And this, in this case, if you see what I got here, very interesting thing is that dqx over dx is equal to minus qg e dot into a. It means whenever heat generation is there, then the rate of heat transfer is a function of x. Yes or no? With respect to change in x, the rate of heat transfer will vary. Yes or no? Bolo. So whenever I have a heat source or heat generation, always the rate of heat transfer is a function of x. Because if you integrate this equation, then you will get q dot x equal to plus qg dot a into x plus c1. Yes or no? Tell me please. But at the same time, if I'm talking about without heat generation, then differential equation become, this will become 0, and that equation simply become dq dot x over dx is equal to 0. So in this case, rate of heat transfer is not function of x. Yes or no? huh. But at the same time, flux may function of x or not, that depend upon the area. If area is constant, then flux will also be constant. But rate is always constant whenever we have no any heat source. Is this clear? And steady state. And steady state. Clear? Now, today we'll discuss some more problem based on this, where area is going to vary and k is going to vary. Clear? So that the things will be more clear to you. How we'll perform the questions when the area is going to vary with respect to x, and when the k is going to vary with respect to temperature. Clear? Ready? Now write the question. So whatever question I am going to discuss, that question is just quality questions, and they are just a revision of whole theories. So please write one question. The first question, is assume steady state one dimensional heat conduction through a symmetric shape shown and here lateral surfaces are insulated. Lateral surfaces were insulated, so that the heat transfer is only in x direction. Clear? And this is what your x direction. So this is what your symmetrical shape is there. Assume that there is no internal heat generation, then derive expression for k as a function of x for these conditions. What condition is there? Area is a function of x here, 1 minus x. This is how the area is going to vary. Temperature as a function of x is given as 300 into 1 minus 2x minus x cube. The temperature profile is given, and the heat transfer rate is 6000 watt, where area in square meter, x is in the meter, temperature is in Kelvin. Clear beta? Listen. So first read the question. How should perform? First read the question carefully. Assume steady state one dimensional heat conduction through the symmetric shape, that is shape here, through which the heat is going to transfer, and since lateral surfaces were insulated, only heat transfer in axial direction. Assume that there is no internal heat generation, means first of all Qg dot equal to 0. That is clear. Derive the expression for k, how the k is going to vary with x. It means in this case k is a function of temperature, then obviously it will vary with x, because temperature, k is a function of temperature, then temperature will vary from here T1 to T2, right? Then obviously T is a function of x, and since k is a function of temperature, then indirectly k is a function of x as well. Yes or no? By T is a function of x and k is a function of temperature. Then you can see this k is also function of x. Is this clear, beta? So first of all, we should go for very basics. I can't use these equations like d2t upon dx square plus qg upon k is equal to 1 by alpha into del t upon del t. Since it's here one dimensional and no heat generation, d2t upon dx square equal to 0. We can't use this equation. Why? Anyone? We can't use this equation. We can't use this differential equation here. Why? Because that equations, anyone tell me why we can't use these equations? Why did we can't use these equations? Santan, Sambit, Ruksar. Because these equations are for the constant thermal conductivity and for the constant area. Arey yaar. Sir, it's also for one dimensional. Sir, this equation is also for one dimensional, na? I have not written d2t upon dy square. K is vary and area is also vary. Mr. Santan, have you watched all lectures? Sir, one dimensional, obviously everything is one dimensional, whatever we discussed so far. Sir, the general differential equation that I derived, del square t plus qg dot upon k is equal to 1 by alpha into del t upon del t, that has a restriction assumption of what? Constant k and constant area. Here area is also going to vary and k is also function temperature. Clear? Area is also vary. Area is also going to vary, na? We can't use these equations. That's why what we should do, you should go for the general differential. We should use a small differential element. Because t is a function of x here, we should go for a small differential element of length dx. So try to understand, sir. So what I told you, over this we should consider a small differential element of thickness dx and apply the energy balance. The energy balance is what? Q dot x and Q dot x plus dx. It is ठीक है? तो Q dot x minus Q dot x plus dx. No generation is there, 0. Steady state 0. Then what I got here, you know very well, since Q dot x plus dx is nothing, it's Q dot x plus del Q dot x over del x into dx. So please write here, then you get minus of del Q dot x over del x into dx is equal to 0. This also implies कि dq dot x over dx is equal to 0. Clear? We have to now again rate of heat transfer is constant here. In that function of x, what we found from the equation, you use from the Fourier's law, minus k a into dt upon dx. Yes or no? Is equal to 0. And this k and this area I can't take it outside of this bracket because it's a function of x. It may be function of x, and yes, it is. Any problem? And if you integrate this equation, then minus ka into dt upon dx is equal to c1, and c1 is nothing, it's called rate. बोलो बेटा. और यहाँ से देख लो dq x upon dx, because हमें निकालना क्या है, we have to find out how the k is going to vary with x. So since here I got q dot x equal to constant, or minus k, from here also minus ka in dt upon dx equal to constant, and this constant value is already given, rate of heat transfer, and rate of heat transfer is how much? 6000 watt. Tell me please. This rate of heat transfer is 6000 watt. Now you can put here minus k, area is how much? How much is the area? 1 minus x. And how can you find dt upon dx? If we differentiate this equation, dt upon dx is equal to 300 is constant, minus 2 minus 6x square. It's a minus of 300 into 2 plus 6x square, or minus 600 into 1 plus 3x square. Yes or no? Please put this value dt upon dx here. It's a minus 600 into 1 plus 3x square. It's equal to 6000. So from this, if you divide, then minus cancel, then k is nothing, 6000 upon 1 minus x into 600 into 1 plus 3x square. This 20 cancel, it becomes simply 10 upon 1 minus x into 1 plus 3x square. So here I got k as a function of x. Yes or no? Bolo. What they asked you? They told you, they asked find the expression for k as a function of x. So what I did, I just go the basics things. Yes or no? I just go for differential element and I apply the balances, and then accordingly everything is given. Minus k a dt upon dx is nothing, it's the rate of heat transfer. Rate of heat transfer is constant. You have already seen rate of heat transfer is constant here, 6000, and then k a and dt upon dx, everything is given here. I just put the value. Yes or no? Bolo. Here I got k as a function of x. Clear? Kritika? Ruksar? Palak, clear? Clear beta? Karthikeyan? Now come to another question. Is steady state one dimensional conduction occurs in a rod of constant k and variable cross sectional area and variable cross sectional area a as a function of x is a naught into e की power ax, ठीक है, where a naught and a are constant, a naught and a are constants. Lateral surfaces are well insulated. Lateral surfaces of the rod is well insulated. So this is what the question is there. A rod is there and rod is of this types of shape. ठीक है, this is what x-axis. Lateral surfaces are well insulated and the area of this rod is going to vary with a naught into e की power ax. Means when x equal to 0, here at this point area is a naught, at this point whatever length is there x equal to l here. So at this point area is what, a naught e की power al है ना, area is going to increases with the direction of x. So the first part of the question is write an expression for conduction heat rate, conduction heat rate, and also find out temperature distribution. And here temperature is T naught and here temperature is TL, and given that T naught is more than TL. Clear? बोलो बेटा. देखो, again what we should do, we should use small differential element of thickness dx and then apply the balances, energy balance on that element. No heat source, steady state, and I got simply dq dot x over dx, that you know very well. Clear? In this case the same concept we should use here. Again if you use d by dx, what is qx minus k into, from Fourier's law, k into a into dt upon dx is equal to 0. K is constant, that I can take it outside. So first of all, since they ask you write the expression for heat conduction rate q dot as a function of x, so from this one thing is clear कि q dot x is constant, it's not a function of x. Now it's clear. So what you should write here, the expression for heat conduction rate q dot x is constant. Clear? And then they told you find the temperature distribution. The first of all, heat transfer rate in this case is not going to vary with x. At all point here, the rate of heat transfer is same. Clear? Now then how can you find the temperature distribution? Then you should write here d by dx minus ka dt by dx, and you know minus ka into dt upon dx is equal to constant called as c1, and c1 is nothing, is rate of heat transfer. Simply k तो कांस्टेंट है, माइनस k, एरिया इज हाउ मच a नॉट इंटू ई की पावर ax इंटू dt अपॉन dx is equal to what, c1, yes or no? And then you can integrate to find the temperature distribution. Then dt is equal to minus c1 upon k into a naught into e की power minus ax into dx. Now you can integrate to find the temperature distribution. Can you find, yes or no? Tell me please. The simple mathematics is there, na? At x equal to 0, what temperature is there? T naught. At any given x, temperature is T as a function of x. So from this, obviously you will get the temperature distribution, yes or no? Tell me please. So T as a function of x minus T naught is equal to minus c1 upon k into a naught e की power minus ax upon minus of a, and limit is 0 to x. This minus minus cancel. T as a function of x is equal to t naught plus c1 upon k into a naught into small a. One time you should put here e की power minus x, and another time put 0. Then e की power minus ax minus 1. E की power 0 is 1. Yes or no? Tell me. So also you can write here t as a function of x is equal to t naught minus c1 upon k into a naught into a into 1 minus e power minus ax. This is what expression is there. And if you plot this curve, what types of expression we are getting? Yes or no? Is this clear? Any problem in this expression? Temperature distribution? Ruksar, Sayantan. Simple mathematical equation is there. And one more thing I told you, if you recall, ki in this case, as I told you, rate of heat transfer is constant. If you see, if you don't want expression, you only draw profile. How can you draw the profile? My dear student, I told you in this case, since rate of heat transfer q dot x equal to constant, and q is what, area into flux at that x is equal to constant. Since area is going to increases, then flux will be decreases in direction of x, and flux decreases. This implies dt upon dx get decreases with respect to x from the Fourier's law. So as x increases, dt upon dx decreases, and you can see also it means the plot of the curve t versus x curve is actually like this. At x equal to 0, temperature is T naught. At x equal to L, temperature is TL. This is what the profile is there. And you can see from here also, at the slope of this curve, if you draw tangent at any point, this will be dt upon dx, yes or no? So flux will be vary from each and every point, but the rate of heat transfer is constant because area into flux is constant. And you can see from here also, my dear student, if you see this equation carefully, what is dt upon dx? Slope. So minus k and area is a naught into e की power ax into dt upon dx is equal to c1. Then what dt upon dx value is there? The thing is c1 minus c1 upon better is that I am going to find the minus dt upon dx, because in direction of x decreases. So it is c1 upon k times a naught into e की power ax. Yes or no? Tell me. And if you see carefully, this is what slope, and as x increases, slope get decreases. Yes or no? Bolo. Because e की power ax is there, or you can say also c1 upon k into a naught e की power minus ax. So as x increases, you see dt upon ds get decreases. That's what I told you. Yes or no, beta? Clear? Yes or no? How can you find the temperature distribution? Clear? How will you find the flux distribution? The flux distribution is very simple. Since q dot x equal to constant and its area into flux is constant c, then q dot x is equal to nothing is c upon area. Area is what? A naught into e की power ax. This is what the flux is going to vary with x. Clear? C1. As x increases, flux get decreases. So q dot x is equal to nothing c1 upon a naught into e की power minus ax. बोलो clear है? Flux. You can find anything. Mr. Sayantan, is this clear, beta? Now listen, I am going to just create the complexity. Are you ready for this? The second part of the question is that the second part, now consider condition for which thermal energy generated in the rod. Now we have heat source, because energy is going to generate in the rod at a volumetric rate q dot is equal to q dot naught e की power minus ax. It's actually the volumetric generation, watt per meter cube. Are you getting? This is the volumetric generation of the heat. Previously we have find the constant, means uniform. It's non-uniform heat generation. Why non-uniform? Because with respect to x, the rate of heat generation is different. Clear? Previously we have seen uniform heat generation. Now here is non-uniform heat generation. Why non-uniform? It's a volumetric. Because it's a volumetric heat generation, qg dot is a function of x, where q naught dot is a constant. then obtain expression for heat flux as a function of x when the left face at x equal to 0 is well insulated. Listen, it is the second part of the same question. Now we have try to understand it. So now in this rod heat source is there, a heat is going to be generated with this rate q naught e to the power minus ax, and area is obviously going to vary with a is equal to a naught into e to the power ax. Try to understand, very interesting. Clear? So you have to find the expression for q dot x. देखो what will happen. Again we should use small difference element, and from this difference element I got this differential equation dq dot x. Sorry, but now this time heat source is there, so we should go for the balance. Then I should write q dot x minus q dot at x plus dx plus qg dot as a function of x into volume. Volume should be dv. Dv is what? Area into dx. Area at x into dx. Yes or no? This is what qg into volume beta. Because its volumetric generation is there, then qg into dv, and volume is area into dx. Area at that x. Area at that x into dx will give you volume. Bolo beta, volume of this differential element over which we are going to make a balance is equal to 0 because it's steady state. कोई problem? Now as you know, the difference of this value will give you del q dot x over del x into dx is equal to minus qg into function of x into area as a function of x into dx. It's cancel, and this become minus minus cancel, this become dq dot x over dx is equal to, listen, what is the heat generation rate is a function of x is given to you. What equation is there? q naught dot into e to the power minus ax. And how the area is going to vary? It's a naught into e to the power ax. So it's cancel, minus ax plus ax, it become 0. Bolo. Here if you integrate this equation, then I got dq dot x. Let's say if I want to find out, they are asking flux, how the flux is going to vary with the x. The first, let's say at any given point x, I just want to find the rate. Otherwise you can directly write, because they are asking not the rate. Suppose first they are asking for the heat transfer rate as a function of x. The heat transfer rate as function of x is q naught dot into a naught plus c1, yes or no, into x plus c1. q dot x is equal to q naught a naught into x plus C1. This is how the rate of heat transfer is going to vary. And if you want to find the flux, then what you should do? Sir, left face is insulated, na? Sir, I have taken the defensive element at x distance from the left face, sir. I have taken the defensive element at this point. It is not at the left face. Sir, at x equal to 0, listen, try to understand. I will discuss boundary conditions. It's only at the boundary, not at all points, sir. This defensive element we have considered at x distance from the left face, Mr. Sambit. Now come to this point here. How can you find the flux? Because this is how the rate of heat transfer is going to vary with x. So listen how much interesting it is in this case, because the heat generation is non-uniform. That's why the rate of heat transfer is also function of x. What the mathematics says. Yes or no? And in this case, because they're asking not for the rate of heat transfer, they're asking for the flux distribution. How can you find the C1? One condition is given, left face is insulated. It means at x equal to 0, no heat transfer is there. Qx equal to 0. Yes or no? At x equal to 0, insulation is there, no heat transfer is there. Then if you put the boundary condition at x equal to 0, then I got C1 equal to 0. Bolo. At x equal to 0, q dot x equal to 0, that's why I got the C1 equal to 0. Then q dot x equal to nothing, it's q naught into a naught into x. And since rate of heat transfer is nothing, area into flux, it's ax into qx is equal to q naught into a naught into x. Then q dot x equal to q naught a naught x upon area as a function of x is a naught into e की power ax. A naught cancel, then heat transfer rate I got as a q naught into e की power minus ax times x. This is what the flux is going to vary. Is this clear? Here in this case, rate of heat transfer is not constant, it's a function of x, that you can see from the expression. Why it's a function of x? Because of non-uniform generation is there. If you see, clear? Any problem to anyone? How can you find the heat transfer expression? कुछ समझ में आया बेटा? Can you find temperature distribution in this case, Jaya? Sir, if x equal to 0, q is equal to c1 or not? Jaya, madam, x equal to 0, q equal to 0 ना madam, क्योंकि left face is insulated. Here, have you read the question, madam? When the left face is well insulated, do you know what is meaning for insulation? No heat conduction at this surface. So at x equal to 0, q dot x equal to 0, that makes C1 0. Clear, madam? Now it's clear, yes or no? Because here you have seen the rate of heat transfer is not constant, it's a function of x. And here we have make a insulation at the left face. Means whatever heat is transferring, that all is going to transfer through only this side, to right face. How can you find temperature profile? Anyone? How will you find temperature profile? Very simple. This is what I got now. Then you can use the Fourier-like equation and then you can find temperature distribution by what way. मैंने क्या लिखा अभी? dq dot x, since dq dot x over dx is equal to q naught into a naught. Yes or no? Then from the Fourier's law, d upon dx equal to minus k into a into dt upon dx is equal to q naught into a naught. इंटीग्रेशन कर दो तो माइनस के ए इंटू डी टी, के इज कॉन्स्टेंट हेयर, तो के को इधर कर लो, बट एरिया इज अ फंक्शन ऑफ एक्स. अदरवाइज आप अंदर रख लो एरिया, के को बाहर कर लो, डी अपॉन डी एक्स. यू कॉन्ट टेक इट ए आउटसाइड बिकॉज ए इज अ फंक्शन ऑफ एक्स. तो दिस इज सिंपली बिकम ए इंटू डी टी अपॉन डी एक्स इंटू माइनस क्यू नॉट इंटू ए नॉट अपॉन के, डी अपॉन डी एक्स. वॉट इज एरिया? ए नॉट इंटू ई की पावर ए एक्स into dt upon dx is equal to minus q naught into a naught upon k. Then integration will give you a naught e की power ax into dt upon dx is equal to minus q naught into a naught upon k plus c1. Clear? into x plus c1, sorry, into x plus c1. yes or no? बोलो. Clear? Then dt upon dx is the slope of temperature profile minus q naught a naught into x upon k into a naught into e की power ax plus c1 upon a naught into e की power ax. This cancel out. Then dt upon dx is equal to minus q naught upon k into x into e की power minus ax plus c1 upon a naught into e की power minus ax. First, again, if you integrate, you can find temperature profile. Okay, one boundary condition you can use here. What boundary conditions? Since at x equal to 0, what about dt upon dx? Anyone? 0. Why? Because no heat transfer is there. And q is equal to minus ka dt upon dx. Because at the left face is insulation, and that is called an insulation boundary condition. I will discuss in the next topic. Whenever we have an insulation boundary condition, then dt upon dx 0, that makes q equal to 0. Sambit, Jaya. So add x equal to 0, this term becomes 0, this term becomes 0, then I got c1 0. This implies c1 0, yes or no? So that term simply become dt upon dx is equal to minus q naught upon k into x into e to the power minus ax. Then for again integrate t, I got here minus q naught. Now here I got dt is equal to minus q naught upon k into x into e to the power minus ax into dx. Now you can integration by part, and then you can find the temperature distribution. That's what I want to show you. It's simple mathematics that you can do, but how can you find the temperature profile? Is this clear? Concept is as it is. First you should take differential element and then apply the balance, and whatever is given you should perform. That's it. Bolo. Kritika. So here you can see in this case, more complex case, area is also going to vary, and heat generation were there, which is non-uniform. If you have any problem, please you can ask me. Kritika, dt upon dx is 0 only at x equal to 0. This I did to put the boundary condition, madam. That makes c1 0. Actually, this is your conditions. Otherwise, you can come to here. This, madam, c1 is a constant. How can I find the constant? By using boundary condition. What boundary condition I have? At x equal to 0, dt upon dx is 0 because its well insulation is there. So at x equal to 0, if I put in this equation x equal to 0 and dt upon dx 0, then that 0 and this becomes 0, this becomes c1 0. Otherwise, you can put here also at x equal to 0, x is also here, it becomes 0. dt upon dx 0, this becomes c1 0. So now in the next dt upon dx, I will not write this term. This term will be 0 because c1 is 0. Is this clear? And here if you further integrate, then I got the other constant called as c2. Clear? Jaya, Sambit, miss, what I want to show you, you should not remember anything. If they are asking temperature distribution, if they are asking flux distribution, if they are asking anything, just you can write. Okay. Now, next come to the topic is boundary conditions, because as I told you, whenever we are solving the differential equations, we are getting the boundary conditions, or whenever we are performing integration over differential equations, I got in constants. So please write down different types of boundary condition. Different types of boundary conditions. Please write. The first is called as specified temperature boundary condition. Specified temperature boundary conditions. It means temperature is specified at the boundary of the surface. For example, let's say this is the face is there, it's x, it's 0, it's L. So here at the left and right faces they will specify the temperature. For example, here temperature is given as a T0 and here temperature is TL. So that it means it is a constant surface temperature at x equal to 0, constant surface temperature at x equal to, means whole right face is maintained at the constant temperature of TL. So that is called a specified temperature boundary conditions. So in this case, can you write at x equal to 0, temperature at x and time t. And listen, what x is there? Here x indicates you 0 and time t is equal to T0. At x equal to L, temperature at L and time t is equal to TL. Is this clear? It means at x equal to 0 means at this point, at time t, and this boundary condition is for steady as well as unsteady state. Why? Because for steady state at all time t the temperature is T0. Yes or no? Because the definition of steady state is that the variable should not be vary with time. So if the system is steady state, then all time t the temperature will be T0. Otherwise, for unsteady state, it is only at the instant of the time t, it's T0. Clear? Similarly, at x equal to L, at time t, temperature is found to be TL. For steady state, this T0 and TL is at all time. For unsteady state, it is only at the instant. Is this clear? This boundary condition means at this boundary and this boundary temperature is specified, and that is called as specified temperature boundary condition. Is this clear to everyone? Jaya. Kritika. Second, specified heat flux boundary condition. Specified heat flux boundary condition. Now, just like here temperature were specified, now heat flux were specified. Let's say this is the face is there, it's x 0 and here L. So for example, let's say the left face were subjected to the constant heat flux. Left face were subjected to constant heat flux. So listen, at this left, I'm talking about only left face. Listen carefully. At the left surface, if I'm going to make a balance, let's say this is what Q0. Q0 is here, and here let's say QL. It's a flux watt per meter square. watt per meter square. So heat flux were specified at the left and right faces. So can I write here at x equal to 0, the Q at x equal to 0 and time t is found to be Q naught. Similarly, at x equal to L, Q at L and time t is found to be QL watt per meter square. Bro, clear? The heat flux were specified. And also, very important thing is that this value now at this point, whatever the heat is going to transfer through the heat flux, that is going to be conducted in this solid by conduction. If I am talking about this surface, I told you if this is surface is there and it is surface, if I am going to assume a control volume, then at this point whatever the heat flux is there, like Q naught, the same is going to be transported in the solid wall via conduction minus K into dt upon dx at x equal to 0. Yes or no? Tell me please. By जो भी heat, whatever heat is going to enter through the constant heat flux, that were transfer in the solid via conduction. So since I am talking about only at x equal to 0, then at x equal to 0 at time t, this is Q naught and this is equal to minus K into dt upon dx at x equal to 0. Yes or no? Tell me. It's a flux, that's why I am not taking area. And this is the temperature gradient only at x equal to 0, because this is the heat flux at x equal to 0. Similarly, at x equal to L, if I am talking about, come to this surface. At this surface, whatever heat is transferred by, if I am going to show you like this, this is the x equal to L, heat is transferring in the solid via conduction minus K into dt upon dx at x equal to L is equal to heat transfer by constant surface heat flux. So I can write also minus K into dt upon dx at x equal to L is equal to Q of L. This is another boundary condition. Yes or no? बोलो भाई. This is called a specified heat flux boundary condition. Yes or no? क्लियर है? At x equal to L, at x equal to 0, that's important. Now third, convective flux boundary condition, convective heat flux boundary condition. Convective heat flux in the sense like this. For example, let's say this is the some fluids are here by convection, here also by convection some fluids are there. This is the slab is there, and here the fluid, surrounding fluid in the left face and right face. Let's say here temperature is T infinite 1, here T infinite I and T infinite naught. Clear? And here x equal to 0 and x equal to L. Clear beta? It means here temperature is T naught and here temperature is, this surface temperature is TL. This right face of the slab is temperature TL, left face is at T naught, and here convection is there, and here also convection. That's a convective heat flux boundary condition. Clear? The same here, if I use at x equal to 0, then if I use this as a differential element, then whatever heat transfer by convection, same is heat transfer by conduction. Energy balance, no accumulation is there because it is only surface. At this, if I am going to show you this surface which is x equal to 0, and if I am going to enclose in a control volume, then it's simply heat transfer by convection, or since I am talking about flux, then I should write here q dot convection is equal to q dot by conduction at x equal to 0. So what convection is there? Heat flux H, let's say here Hi and here H naught. Here fluid in the left face have heat transfer capacity Hi and right face have H naught. So Hi into T infinite I minus T naught is equal to minus K conduction minus K into dt upon dx at x equal to 0. Yes or no? Similarly at x equal to L, at this point if I am talking about, again the same, Q conduction equal to Q convection. I can write here minus K into dt upon dx at x equal to L is equal to H naught into TL minus T infinite naught. TL minus T infinite naught, yes or no? Bolo. This is called as convective heat flux boundary condition. बोलो बेटा. Is this clear? Fourth, interface boundary condition. Interface boundary condition. Interface means, let's say you have a two slab. One have thermal conductivity Ka, other is of Kb. Two different material is there of different thermal conductivity. Okay, and this is what interface is there. Let's say I'm talking about this as a x-axis 0, let's say L, this is let's say 2L. So where is the interface? Interface means where the two different materials are going to be attached. So this is your interface. The interface is also a surface. So if you're talking about this interface, then the rate at which heat is transferred by conduction through material A is the same rate heat is transferred through material B in material B, because this is only surface and surface can't accumulate because its mass is 0. Very thin element we have of this interface we have considered. So can you see at the interface, if it is interface is there, minus k of a. Listen, because in the before L the material is a, so k of a into dt a upon dx, and here minus k b into dt b upon dx. Yes or no? This is the temperature gradient in material A, temperature gradient in material B, that indicates at x equal to L, at x equal to L, where L is the interface. Can you say? Because they are both of solids. So at interface, minus ka into dta upon dx at interface is equal to minus k of b into dtb upon dx. That you must know. This is only here interface is at x equal to L. That's why I shown you like this. Clear? This is called interface boundary conditions. Clear? बोलो भाई. Now the next boundary condition is called as insulation boundary condition. Insulation boundary condition. What do you know by insulation? Let's say this is the slab is there, and there this face is insulation. Let's say I made insulation at x equal to 0. If I made insulation on this face, then at this face what happened? dt upon dx will be 0. Because no heat transfer through this phase, that's why dt upon dx is 0. So at insulation surface, dt upon dx equal to 0. So the surface at which you have made the insulation, at that point, here in this case at x equal to 0, dt upon dx 0. Suppose I have another surface like this, and I made insulation at x equal to L. So what should I do? I write here at x equal to L, dt upon dx equal to 0. This is no gradient, means no heat transfer is there through that phase. This is called as insulation boundary condition. Is this clear? Below. And the last is called a symmetrical boundary condition. Symmetrical boundary conditions. The last boundary condition is called a symmetrical boundary condition. So this boundary condition we should use to find the constants. In symmetrical boundary conditions, let's say what I'm saying to you, if a hot plate is going to be subjected into environment of same temperature throughout, this is the hot plate is there, and this hot plate we have subjected to the environment on the both side by the same temperature, T infinite here, T infinite here, H is also same, H is also same, everything is same. If you can write here, if a hot plate is subjected into an environment for cooling, if a hot plate is set to environment for the cooling, it means both side the same environment is there. In this case, there is symmetry about center, and center surface acts as insulation. What does it mean here? But listen, when you place in the same environment, then everything in the left half of the mid plane same in the right half. This symmetry means what? Equality. So whatever temperature profile is there in the left, equal mirror image in the right. Mirror image means here surface temperature and here surface temperature will be same. If let's say, if at 1 meter from here temperature, the same temperature is also from 1 meter from the right. Everything just mirror image, profile, convection, the same. Everything in the left mid plane is equal to mirror image to the right mid plane. Just mirror image. Temperature of the surface in the left and right will be equal. And if this is the case, then in this case the center of the surface, you can see here at the center, dt upon dx will be 0. You can see here profile. Since there is a mirror image, then that will lead to the maxima at the center. And the maxima at the center means at the center of surface dt upon dx becomes 0. Because center of surface will act as an insulation. Is this clear? At the center. But it's only possible when there is symmetry about the both side. Clear hai? All boundary conditions are clear. So these all are different boundary conditions. Now please write one, because sometimes we should go for the specific formula for the specific cases. So here I am going to write cases is temperature distribution in a plane wall for one dimensional steady state heat conduction with uniform heat generation. What is the meaning of uniform, beta? With uniform heat source. Uniform means Qg is not function of x. As in the last question, we have seen Qg was function of x. Are you ready? So what I'm going to see here, this is a plane wall, and its thickness is 2L, minus L and plus L, and this is the center is here, x equal to 0. Clear hai? And because there is uniform heat generation is there, means obviously there is a Qg is there, then how should write the differential equation? Now here area is constant, yes or no, and k is constant. They have not given any information about k constant hai. Then I can use write directly differential equation that we derived. For this case I can write d2t upon dx square plus qg dot upon k is equal to 1 by alpha into del t upon del t, but it is 0 because of steady state. They hate this. Now you can write. Otherwise again you can assume differential element, or listen, or you can again follow the same process. You should assume differential element on this, and then you can follow the q dot x and q dot x plus dx if you want. But as you know, we already have a equation for the constant area and constant thermal conductivity. Then you should write this. Clear? Then d2t upon dx square equal to minus qg dot upon k. dt upon dx equal to minus qg dot upon k into x plus c1. So temperature distribution is a function of x. First of all, I got here non-linear profile is there, slope will be changed from x to x. Then t as a function of x equal to minus qg dot into x square by 2k plus c1 x plus c2. Now to find the temperature distribution we must know c1 c2, and to find the c1 c2 we must use the boundary conditions. And since the uniform heat generation is there, then the rate at a steady state, what happened? At steady state rate at which heat is going to generate, the same rate heat is to transfer to left and right phase. No accumulation should be there. And if the left and right phases were at the same condition of environment h, t infinite, then there is symmetrical boundary condition I should use, yes or no? And the surface temperature will be same here. The two constant boundary conditions. The first boundary condition is at x equal to plus minus L, what temperature is there? Ts, bolo beta. Plus L and minus L temperature will be same. It's Ts here, also here Ts. Because symmetry is there. Every environment is same in the left and right phase, that's why there is symmetrical condition will be there. Yes or no? Second boundary condition is what? At x equal to 0, what happened, beta? Since symmetrical boundary condition, you use please this boundary condition, symmetrical boundary condition. At x equal to 0 means center surface, not left phase. Here left phase is minus L. Because of symmetry is there in the left and right phase, that's why the center of the surface will act as insulation. Then at x equal 0, dt upon dx equal to 0. बोलो बेटा. And this is nothing, it's the last boundary condition called symmetrical boundary condition. I told you. These two boundary conditions will be required to find out the constants. So if I put second boundary condition in this equation, then I got C1 0. Equation first, second, third. From equation 3 we got C1 as a 0. Yes or no? तो C1 यहाँ भी 0 हो जाएगा. Then t as a function of x is equal to nothing minus qg dot into x square by 2k. Find the C2. What should I do? I should use this boundary condition at x equal plus L or minus L, temperature is Ts. So please find the C2. Here temperature is Ts minus qg dot either plus L or minus L. Square will be only L square by 2k plus C2. This implies C2 equal to Ts plus qg dot into L square by 2k. Please put the value of C1 C2 in this equation. C1 is already 0, C2 I told you. So this profile is t as a function of x equal to minus qg dot into x square by 2k plus C1 is 0, C2 is Ts plus qg dot into L square by 2k. Then t as a function of x minus Ts is equal to qg dot into L square by 2k. You can take common, then become 1 minus x square by L square. Please check. And this is the parabolic equation is there. That you should remember, because this is, but at the same time you must remember what the restriction of this formula is there. So how the temperature is going to vary with x, Ts plus, and this is the parabolic equation. If you draw on this types of profile you are getting here, equally mirror image in the left and right. Whatever in the left, same is in the right. Means equal rate of heat is transferring the left and right. Clear? So this equation I got as a t as a x minus Ts is equal to qg dot into L square by 2k into 1 minus x square by L square. This equation where L is the half of thickness, yes or no? Because 2L is the length, 2L is the thickness. Be careful. Here very important thing is that here L is half of thickness of slab. Half of thickness of slab. It means if length is 40 millimeter, then we should write here 20, because here we derive this equation for 2L thickness. 2L is 40, then L is 20. Is this clear? And where is the maximum temperature? At which point there is a maximum? You can see this equation will be maximum only when x equal to 0. So T max, T become T max at x equal to 0, means at the center of the plane. So T max minus Ts, it means difference in the maximum temperature and surface temperature, is equal to Qg dot into L square by 2k. Clear? Maximum temperature, and the maximum value is what? Ts plus Qg L square by 2k. You can see the maximum is at the surface here, T max. But it is only possible to maximum center when there is symmetry is there. Yes or no? Now my question is that in which condition you can use this formula? You know through derivation you know the restrictions. What are the restrictions are there? Please tell me. First of all, Qg L square by 2k 1 minus x upon L ka whole square. L is nothing, is a half of thickness. Second is you can't use this equation when the k is going to vary. You can't use equation when the area is going to vary. It's valid for uniform area through constant thermal conductivity and with uniform heat generation. If non-uniform heat generation is there, then Q is a function of x. You can't write this. Is this clear? And where there is a symmetrical boundary conditions are there. And where the symmetrical boundary conditions are there. In those cases, if your conditions are satisfied, then only you can use these equations. Otherwise, go for the basics. Clear? So whatever numerical problem I have given, try to solve from your own. Take a rough copy and try to solve from your own whatever questions I have discussed. Clear है? Yes or no? Now, write one question. Ready? बोलो भाई रेडी हो? Now write down one dimensional steady state conduction with uniform internal energy generation occurs in a plane wall. with thickness of 40 millimeter and a constant thermal conductivity of 5 watt per meter per Kelvin. ठीक है. For these conditions, temperature distribution T as a function of x equal to a plus bx plus cx square. The surface at x equal to 0 has and here figure is given, so you should know what x equal to 0 here. You should not consider x as a mid center. The surface at x equal to 0 until unless they have not given कि 2L is 40 millimeter, है ना. So if because here they have simply give you thickness is to 40 millimeter. Others, okay. The surface at x 0 has temperature of 130 degrees Celsius and experience convection with the fluid, convection with a fluid for which T infinite is 30 degrees Celsius and H equal to 500 watt per meter square. The surface at x equal to L is well insulated. Clear? The figure is given, and first of all, if they have not given कि length is 2L, then always you should assume length L is 40 millimeter. If L is 40 millimeter, then x equal to 0 is only at the one face. So this is what your slab is there. A one dimensional is the, how can you understand the question? One dimensional is steady state conduction. Uniform generation is taking place. QG is there. Uniform heat generation is there in the slab. In a wall with thickness of 40 millimeter is there. So let's say this is what x is there. This is 0 and this is L is 40 millimeter. Clear? A constant thermal quantity K is given as a 5. K of this material is 5 watt per meter per Kelvin. For these conditions, temperature distribution is given T equal to A plus Bx plus Cx square. Temperature distribution is given. The surface at x equal to 0 has temperature of 130. Here temperature is 130 degrees Celsius. Clear? And experience convection with the fluid, means this surface. This surface is at 130 degrees Celsius and experience convection with the fluid of T infinite 30. Here the fluid is, which temperature is 30 degrees Celsius T infinite. So it's very obvious that this face is 130 and this is 30. It means heat is transferring in this direction by convection. Yes or no? By convection. Because it's given. The surface at x 0 has temperature of 130 and experience convection with the fluid with T infinite is 30 degrees Celsius and H is what? The H is 500 watt per meter square. Is this clear? Surface at x equal to L is well insulated. This is L and this is well insulation is there. And whenever we have insulation, it means at the insulation surface dt upon dx equal to 0. At the surface of insulation dt upon dx is 0. बोलो. Is the question is clear to everyone? Means no heat can be transferred through right phase. All the heat transferred through the left phase. And since it is steady state, then what happen? Means total heat generation should be equal to total heat transfer by convection. That's very obvious. At a steady state, the first part of the question is find the QG. QG dot. Value of QG dot. How can I find the QG dot? Anyone? Because here if you write these equations, then you don't know A, B and C. But one thing is that if you go for overall energy balance, because one information is given to you कि steady state is there. So at steady state the total heat generation is equal to total heat removal. If you go for overall balance of energy, then you know E dot in minus E dot out plus E generation is equal to E stored. Since steady state no stored is there. E in is equal to how much E in is there? Energy in I will discuss in here. So E in is nothing H into A into I will write in terms of T infinite minus, because I am assuming in here. Already minus sign and plus sign is here. So H A into 30 minus 130. E out is nothing here because insulation is there. E out is 0 is equal to E generation. Yes or no? Tell me please. Then E generation is equal to H is given 500. Area is A, let's say, and this is minus 100. Then minus minus become plus 5 into 10 power 4a. It's a watt. But they're asking QG. So what is EG? EG is QG into volume. This is nothing QG into volume. Generation. Volume is area into length. Length is given 40 millimeter, means 0.04 meter. This area cancel. Can you find the QG? Is 5 into 10 power 4 upon 0.04. Tell me how much answer is there. This is through equations. Very simple. Otherwise, if you feel logically, भाई जो भी heat generation हो रहा है इसके अंदर, total rate of heat generation should be total heat removal. At a steady state, no accumulation should be there. Yes or no? Because now here you can see, sir, why you have written 30 minus 130. Here I have written because this I have assumed in, and if in value is negative, negative indicates you it is going to be out. That's why already sign convention is there. Clear? Clear? What is QG, Mr. Abhishek? Kritika? or you can also see simply, or at steady state also you can write a rate of heat generation equal to a rate of heat removal removed by convection, total rate of heat generation. The total rate of heat generation is nothing, it's Qg into volume, total volume, and rate of heat removal by convection means only through here left plus right, but right face is insulation, no is from the right, only from the left. So through the left I should Ha into 130 minus 30. Clear? And this implies Qg area into length is given 0.04 meter, H is given 500, area into 100. Please solve. Then Qg dot equal to 5 into 10 power 4 upon 0.04. How much watt per meter cube? Because no heat can be transferred to the right face, only heat transferred to the left face by convection. बोलो भाई, भाई आंसर तो बोलो यार. Watt per meter cube. Is this clear? Here I am talking only magnitude here, but here in this case it's also, you can go for energy balance, you got the same answer. Mr. Abhishek. Yes. Next is, second part of the question is, find the coefficients A, B and C. Find coefficients A, B and C by applying boundary conditions. By applying boundary conditions. As I told you, temperature distribution क्या था बेटा? This is A plus Bx plus Cx square. Question is, how can we find A, B and C? Three constant, three boundary conditions we should use here. How can you use these boundary conditions to find the constants, to find the temperature profile? The first, if you see, at x equal to 0, temperature is given 130. First is, at x equal to 0, temperature is 130. One information is given. Second boundary condition is what? How much boundary conditions we are getting here? One is here specified temperature boundary condition, Santan. One is specified temperature, means at this surface temperature is specified. Second is insulation boundary condition at the right face. At the right face insulation is there, means dt upon dx is 0. At x equal to L, dt upon dx is equal to 0. So if you put the first boundary condition, then at x equal to 0, then I got A as a 130. And if you put second boundary condition, which is dt upon dx equal to 0, means what dt upon dx? It's b plus 2cx, which is 0 at x equal to L. but again means B is equal to minus 2cx through C into L at x equal to L. Yes or no? So we must know one more information about the B is equal to minus 2C, L is given 0.04. So B is equal to minus 0.08 C. So one more information is required to know the relationship between B and C. What the second boundary, what the other boundary condition is there? Below. One more boundary condition is there. Out of 6 boundary conditions I told you, I told you 2 here. Specified heat flux, specified temperature and insulation boundary condition I told you. Is there any other boundary condition here? Yes, Santhan. Is there any other boundary condition except for the 2? Yes, this is called as convective flux boundary condition. Very good. Convective flux boundary condition. And it is at which surface? Convective flux boundary condition. And this is at x equal to 0. Yes. So if you see at x equal to 0, this is the surface is there. At x equal to 0, convective heat flux boundary condition is there. Now very important. Here heat is transferring like this. It means can I write this in this way? So how should I write? Anyone? Can I write ki minus K A minus, because heat transfer by conduction equal to convection? Q conduction is equal to Q convection. So if you say think conduction is minus K into dt upon, let's say I am talking about flux, the small q, the area is not going to matter here, minus K into dt upon dx at x equal to 0 is equal to h into 130 minus 30. Should I write in this way? My dear student, that is the very important point you should bother about. Can I write in this direction? I have written minus K dt upon dx. I can't write. Why? Because if I writing in this way, then I got dt upon dx is negative. And while if you see carefully, dt upon dx is positive here. Slope is positive. If you draw tangent in this figure, my dear student, here the tangent if you drawn, this is positive. Yes or no? Slope is positive or no? Is positive here. Yes or no? So why I can't write minus K dt upon dx here? Because in the formula of Fourier's law, q is equal to minus K into dt upon dx, where minus sign indicates what? Tell me. This is very important at work here. And this will be clear your one more concept. If it is x here temperature is T1 and here T2 and T1 is more than T2. In this case, I can write q equal to minus K dt upon dx, because temperature get decreases in direction of increasing x. Clear? No issue. But if I am going to write in this way, same x is there, its temperature axis, and here temperature is, let's say, T1 and here is T2, and this in this direction. How can I write the heat flux? How can I write the Fourier's law in this case? Q dot. Tell me. Which equation of Fourier law I should use here? should I write also here minus k dt upon dx or not? You should write each and every point. Here x is there. Which Fourier law I should write here? Minus k or plus k? Yes, it's a plus, because listen, why it is going to be correct mathematically and physically as well? Because minus sign in the Fourier law only indicates in direction of increasing x temperature decreases. Here in direction of decreasing x temperature also decreases. That's why there is a plus sign. Here only in this case of increasing x temperature decreases. Yes or no? But here in this case with increase in x temperature get increases. Increase in x temperature get increases. That's why I have plus sign. Is this clear? Yes or no? And you can see if dt upon dx here it is positive, then q is negative, and that indicates you, sorry, here dt upon dx is what? Tell me. As x increases, temperature increases. बोलो भाई क्या करना चाहिए? What should we do in this case? Anyone can give the answer? Yes, obviously. Obviously, the dt upon dx will decide the direction of heat flux as well. So listen, yes, it's a very clear. Here also I should write the minus sign. Why? Here in this case dt upon dx is obviously, as x increases temperature decreases, dt upon dx is negative. Then negative become positive, then heat is transferring the positive x. Clear? Here in this case heat is transferring in the negative x. Is this clear? So negative means q should be negative, and negative is only here if here minus sign is there. Yes or no? Bolo. So dt upon dx is positive, but the heat flux is negative. It means that indicates you कि heat is transferring in the negative x. Is this clear? बोलो. क्लियर है या नहीं? भाई देखो ना, q this will also define the direction. तो q is in negative x. भाई q heat transfer negative x में हो रहा ना, that is only possible when dt upon dx is positive. अभी क्लियर है नहीं? तो now come to this point here. Since I am talking about in this case q conduction equal to q convection, so if I am writing here directly minus sign, then what happen? This also include direction. So I got the value of negative minus, so that's why there may be a mistakes. That's why what you should do, you should be careful in this case. What I am saying to you, always write the balance in positive x, and accordingly you should change your data. Because if you writing here minus here, and this minus sign includes direction, but this does not include direction, it's simply magnitude. Is this clear? So that's why always my suggestion is to you, in this case convective heat flux. For example, here at x equal to 0, obviously I should write the balance in this way. Always write the balance in the case of positive x, interface boundary condition. So interface boundary condition you should always write in the positive x, like in this case. Let's say surface is there, always write the balance like HA into T infinite minus Ts is equal to minus K into dt upon dx at x equal to 0. Then always you will get correct value. Otherwise here you will get some minus mistakes. Clear? So what is there? H, this is area is not there because h is there. Now h is how much? 500. How much T infinite is there? If you see how much T infinite, 30 minus 130 is equal to minus k is 500, and dt upon dx at x equal to 0 is how much? If you see dt upon dx at x equal to 0, dt upon dx is equal to b. How much b is there? So b is 500 into 100 upon minus 500. Let's cancel out. B is equal to minus it's a minus also, no? So minus 100, yes. It's a minus 100. Then it becomes simply 100. Yes or no? Bolo. Clear? Yes or no? Because if you write in this way, then you should balance the magnitude. That's why although the heat is transferring in this direction, no issue, but you should always write the balance in the positive x, and you should write simply minus k dt by dx. Clear? Because here you are writing magnitude and here you are writing direction. That's why it's a mistake maybe there. Clear है? Yes or no? Kurtika. So what is the value of B is 100. Now it's clear. Now once you got the B, you can find the C. I'm sorry. Okay. K is 5. Then what the B is there? Upon 5. Then what the B is there? dt upon dx at x equal to 0. One thousand or 1 into 10 power 4. Clear. Very good. कोई problem? So only thing is I will suggest you, although heat is transferring in this, then you should always make a balance in direction of x. In direction of x, and you can directly write h a into like this, and you can find the correct answer always. Otherwise you should write the magnitude only. Clear है? बताओ. I got the B here. Once I got the B, then you can find the C as well. So how much C is there? C is equal to B upon minus 0.08. How much C is there? Please tell me. And listen, if you see all the terms are positive, I think na. So T profile I got here 130 plus A plus BX. How much BX is there? B is 10 power 4 x plus C is how much? 1.25 into 10 power और 12.5 into 10 power 4. 1.25 into 10 power 5 minus में आ रहा है क्या? Yes, I think it's minus ना. Okay, minus x square. Yes, this is what the profile is there. And what type of profile is there? Can you imagine? Where is the maxima? Where is the maxima? If you know this temperature, then maxima is only where dt upon dx equal to 0, and dt upon dx is 0 in only at x equal to L. बोलो बेटा. Then here this is the dt upon maxima is only where the insulation were there, because no heat is transferring to this side. That's why the maxima is only, all the heat is only here, and then this type of profile you can expect like this. This is about the profile. 130. How much is the maximum temperature? Can you calculate? and here 30 degrees Celsius. How much is the maximum temperature? How can you calculate? By how can you find the maximum? Maximum is only by the function of x is given. Then you should differentiate, and dt upon dx is 0 only at x equal to L. You can check, because already if you see differentiation dt upon dx, and dt upon dx is 0 only at x equal to L. भाई यही तो 0 है ना. Only at x equal to L means 0.04 meter. And what is the value of that maximum temperature? Put T max, put x equal to L here. So 130 plus 1 into 10 power 4 into 0.04 minus 1.25 into 10 power 5 into 0.04 का square. Please tell me how much is the maximum temperature is. (330 degrees Celsius). Very good. Clear? And obviously, wherever the insulation were there, that point the maxima will be there. Shantan, minus 125 into 10 by 4 or minus 1. क्लियर है? बताओ कृतिका. तो Kritika, what is the value of that's all a part of calculation, you can check from your own. What the value of C you are getting? ठीक है. Now one thing, what will happen if I reduce the value of H with half? H was 500 now. If I reduce to 250, then what happen? Anyone? And rest remains as it is. Try to imagine. What is meaning for? Try to understand physically. When H become half, H means when H become half, what does it means? Still the system is steady state now. So if you see, by now the rate of heat generation is same as it is, and rate of heat generation is nothing, it's Qg into volume. And how much Qg we are there? We have already calculated in the last. How much Qg you have calculated, beta? Qg where? How much Qg were there? My question is that if Qg remains same, means rate of internal heat generation remains same, and if I reduce the value of H to half, how much Qg were there? Tell me. How can you think in this? Qg, the Qg into volume is equal to again same H A into 130 minus 30. I am just only equating magnitude. Tell me. How much Qg were there? Qg into area into 0.04 is equal to H into 100. Qg कितना आया था बेटा? Then one thing I would, आप लोग बताओगे नहीं यार. One thing is very important. If I reduce the value of H, है ना, still one thing is same. Do you know what is same? The rate of heat transfer must be same because steady state is there, na. So even the system is steady state, means the rate of heat generation was same. But now the H has been decreased. H decreases means resistance. What is resistance? 1 upon H. A is resistance in the fluid. Resistance in the fluid will get decreases. If the resistance in the fluid get decreases, then there is a more drop in temperature will be there for the same rate of heat transfer. Are you getting? Because Q is equal to HA into delta T. If Q is remain same amount of heat has to be removed from the system. Now H become half, then temperature drop should be twice. Then only it will be equated, yes or no? Bolo. And temperature drop means what? Ts minus T infinite. And T infinite is still same, then Ts has to be increases. Then surface temperature will get increases, yes or no? Tell me. One more thing, for example, try to understand. This question has been asked in the BRC. Listen, this is the slab is there. In this slab, there is a heat generation where there. Clear? This surface I have insulated. Now it's clear. If this surface were insulated, no heat transfer to these surfaces. All the heat generation is through only by convection in this fluid. Surrounding fluid is at 30 degrees Celsius. You can't change the surrounding temperature because surrounding is a reservoir. Okay, now initially I got when Qg was, let's say, at some instant, at some value of Qg, at some value of H, I got surface temperature as a 130 and here 30. I got this profile. My question is that when H become half, then what happened? And Qg will remain same. If you use common sense, sir, Qg is same, then rate of heat generation is same, then Q dot, which is Qg into volume, will remain same. The same rate of heat transfer now is by convection again, H into A into delta T, which is Ts minus T infinite. Qg into by area and volume is not changing. Its area into length is equal to H A into Ts minus T infinite. Area cancel out. Length is same. Qg is same. If H become half, then temperature difference will be twice. And temperature difference will be twice. It means if T infinite is remain same, then Ts has to be increases. For example, if H become half, then difference should be twice. Yes or no? To make the same value of rate of heat transfer. So what I'm saying to you, now let's say Ts dash is the new minus 30. Is 2 times of Ts minus 30. 2 into 130 minus 30, it means it's a 200. Then Ts dash is equal to 200 plus 30. It means it's become 230 degrees Celsius. So yes or no? Tell me please. Which was initially 130, now it's become 230 because temperature difference has to be increased by twice to make the same value of heat to be removed. Is this clear? So first of all, what I got, temperature, surface temperature will get increases. Yes or no? So if you compare here, it's 30, it's for 130, now it's become 230. Now but this temperature will remain same. This would be the profile beta. Yes or no? Tell me please. Now one thing is clear. The second thing, what about the maximum temperature? Will it increase or decrease? What about maximum temperature? Will it increase or decrease? Maximum temperature at, let's say here insulation is there, for example. And what about the listen, how can you find this, my dear student? Try to understand. If you see, again use the boundary condition. Through boundary condition you will get the answer. This one thing is that when I reduce the value of h to half, then I got temperature difference become twice. This I told you. Then surface temperature has been increased. What about gradient at the wall? As you know, whatever heat is transferred at, if you use the boundary condition at the surface, then minus k into dt upon dx, this should be h into ts minus t infinite, or this should be equal to what? Qg into volume. By this is equal to Qg into volume na, batao. Or you can say also h into A, चूंकि volume लिख रहे हो, that's why area should multiply here. Clear? So let's say what I'm saying to you, by whatever is going to be generated, that is going to be transferred by conduction in the material. So at x equal to L, here in this case x equal to L I'm talking about, is also equal to h delta T. So what about gradient? So as I told you, Qg into volume remains same, then dt upon dx will also remain same. That will not be changed. Yes or no? Then whatever the slope is there, so try to understand, very very important thing is there, although I will clear in next lecture also. So if this is the profile and now this is the new profile I got here, but what is same here? Gradient will remain same. Temperature gradient at x equal to L will remain same. Why it is same? Because from this sequence, whatever heat is transferred by conduction, same is equal to by convection, and convection is nothing Qg into volume, or the rate at which heat is transferring at the surface. This is Qg into volume. Qg into volume is same na, then dt upon dx will same, then slope or gradient will be same here. And if the gradient will be same, then obviously here I got this types of profile, then here I got this, obviously the maximum temperature will get increased. T maximum will get increases in the material, and everywhere the gradient will be as it is, but only the temperature has been increased. So slope in the material at any given point, the dt upon dx will remain same, but the only thing is that its value get dt upon dx remains same, but only it is going to be shifted to up, because maximum temperature will get increases. Is this clear? And that's is the only very important, because if you are reducing the value of h, you are increasing the resistance for the heat transfer. And what is q is equal to h a into delta t for the same rate of heat transfer. If resistance get increases, means h will get decreases, then delta t will has to be increased. Temperature drop has to be increased. Is this clear? Bolo. And how can you increase and decrease the value of h? By increasing the speed of the flow of fluids. Suppose I use blower. Previously no blower was there. If you are going to increase the blower, or if you are going to off the blower, then h will get decreases. If you are going to on the blower, then h will get increases. Why? Because increasing the velocity of the fluid will increase the heat transfer coefficient. I told you in the convection chapter, heat transfer coefficient is strongly influenced by the flow field. More the h, less the resistance for the convection. Clear? Although I will discuss this topic in more detail about next lecture. Sunday and Monday there is no classes there. On Tuesday evening I will take the class. Hai? So you have 2 days to revise the whole topics that whatever discussed so far. I will take time in conduction, because this is the only basics that you know. So I think today's is 6th lecture na. In 6th lecture I think you got more clarity about the topics that we covered. You should not bother about whatever we have not covered. You should only clear the topic that I had covered, because I have to cover more things about the conduction still. We discuss about the composite solid, heat composite solid, then I go for cylinder, then sphere. Till now I only discuss everything about the plane wall or Cartesian coordinate. Clear? Thank you so much.